evening, wherever you are in the world, and welcome to this Axon Server intro webinar. So today I'm going to be talking all about Axon Server, but before we do that, we're actually going to cover some of the concepts first. Why would you even use it? So I'm going to start by explaining a little bit about what's the need for and the requirements of a messaging platform and of an event store, right? Why would you want to use them? How would you use them? And what do you need from it? Now, after we've looked into that, after we've covered those bases, then we'll look into, how Axon Server can meet those requirements. Then we'll look at the feature set of Axon Server, both the standard and enterprise features, how it could fit into your application landscape, and finally, how to obtain Axon Server and get started with it. There will be time for questions at the end. So if at any moment you have a question, just type them in the chat, and towards the end, I will go over them. But first, the basics. Let's look at messaging platform, right? What do we need from a messaging platform? If we're going to do applications, microservices, or monoliths, doesn't even really matter. At some point, you're going to have to send messages. You're going to want stuff to happen. You're going to want to inform other components that stuff has happened. Messaging is simply a basic need. But really, there's quite a bit of difference in the types of messages that we can send, right? Not every message is the same. Not everything is an event, for example. And for different goals of those messages, we then also have different routing requirements, right? Maybe we need to send certain messages in a synchronous exchange. So have a request-reply mechanism. While other messages we can simply send asynchronously, just a fire and forget. We send a message and we don't really care how it is handled or not. That's for the downstream components to take care of. We can also stream messages, right? For example, events, to stream them to other components, one after another, and even distribute work using a fan out and then later a fan in mechanism, where we send one message to multiple locations, or we get from multiple locations, we collect the messages in one single location again. Now, to see how and when you would want to use these kind of different patterns, we also need to first see, what does an application look like if we're really using those messages as the basis of our communication? And that will look something like this. So here on the left-hand side, we have some kind of UI, some API. Doesn't really matter too much what it is. What does matter is that it can send two types of messages. It can send commands that get handled by command handling components, and it can send queries that can be handled by query handling components. And in between, these two work together with event sourcing and CQRS by saying, okay, whenever we handle a command in our command handling components, we will consult the event store, we do event sourcing, we get the current state of our aggregate, our entity, our domain model, really. And then based on that, we can do our reasoning and we can publish events, which those can be handled again then by event handling components to update some kind of projection database from which we can then finally answer those queries by consulting the right information. Now, if we look at this, we have three types of messages. Then I already mentioned them: the command, the event, and the query. And each of these types of messages have a different purpose, and as such, they're also going to have a different routing pattern. So first of all, if you want to do something, you would send a command, right? The command is simply the intention to say, hey, I want to do this. Make this change, withdraw money, deposit money, whatever makes sense for your domain. But have anything done. Now, if something has finally happened then, typically as the result of a command, you would publish an event, which is that notification that goes out through whoever is interested to say, hey, this has happened. And if we want to know something, we want to get certain kinds of information or state, we would send a query message that says, hey, I need some information, which obviously gets a response because it's all about the response with the queries, right? So you get that information back. Now, each of these would require a different routing pattern. So if you want to send a command, what's very important with commands is that they are consistently routed to the same fitting handler. If, for example, I have one bank account and I want to do two transfers from that bank account to a different bank account, now they need to be handled by that same handler consistently, so that I can actually handle them one after another. Because if my balance on my bank account is, let's say, $150, and I want to make two transfers of $100, the second one would obviously fail because we can't go into the negative. We can only ensure that if both of those commands are handled by the same fitting handler. And of course, since command can fail, because when we send the command, it's really only an intention to do something, it's up to the domain model to still decide what do we do with it. We require some kind of confirmation or result of that handling of the command. As such, because we require that confirmation, the command requires a synchronous exchange. So we really want to get that reply. We're going to wait for that. Because we want to know if the command got accepted or if it got rejected. And if it got rejected, why did it get rejected, right? For example, insufficient funds in an account. An event has a very different routing pattern. Because an event is simply something that we publish because something has already happened. So we're merely informing the rest of the world, hey, this has happened, right? Money has been withdrawn from this account. So we can distribute it to all fitting handlers. An event can be handled multiple times as such, right? While a command would only be handled one single time, an event can be handled in multiple places in every single handler that is interested in that event for one reason or another, either to update a projection, maybe to send emails or do other kinds of secondary actions. Events, they do not require a result. So this is an asynchronous exchange. We send an event and it's up to all these individual handlers to do with the event what they need to do with it. If they don't like the event, just like in the real world, right? It's history. If something has already happened, if we don't like it, the only thing we can do is we can change how we deal with it. We cannot go back in time and change an event. So that's why events can be an asynchronous and change. We just don't have any result. Here you go. This has happened. Deal with it. And then finally, we have the query routing. And with the queries, there's actually the most variation possible. You can have a simple synchronous exchange. If you just send a query, you want to know a bit of information, it goes to one single location, you get your reply, and you're done. But you can also alternatively use a fan out and then a fan in to send that query in a sort of more distributed fashion where you say, okay, I'm going to send my query. I want answers from all possible handlers. And then I'm going to collect those answers and reduce them to something that makes sense to me. For example, right, if you're searching for flights, you have plenty of those websites that collect flights or really flight information from all kinds of different airlines. So they would probably, of course, what going on in the back is a bit more complicated, but basically they would send out queries to each of those different airlines to say, hey, for this itinerary, do you have flights for me? You collect all the results, you display them, maybe you sort them nicely based on what's the cheapest or the shortest time or whatever criteria you use there. And then you do something with it, mostly displaying it or using that information, because that's really what queries are all about, right? It's about obtaining that information in one way or another. Now, to send all these messages with these different routing patterns, we would require another component, which is called a message bus. A message bus handles routing and discovery of all those messages to move a message from one component to another and to potentially also move the reply back. Now, if we do all this messaging through a message bus or through message buses, really, that handle that routing and discovery, then we enable location transparency, where we can say, well, any component, here indicated by these different colors, any component is neither aware nor makes any assumptions of the other components that it interacts with. So if I'm this purple component and I send a command, I don't need to care that the yellow component, for example, is the one that's going to be handling it. All I care about is that I send it on the bus and the bus takes care of it, that it arrives at the proper destination, and eventually a reply will come back to me that will inform me if it succeeded or not. Same with the other types of messages. Now, if we do our communication through that, then later we can say, well, if we want to pull out this purple component and later pull out more components, we can still send those same messages in the same way on those message buses, right? The only thing that changes is that in the single instance, you have just a local message bus, while if you have multiple instances, you will need a distributed message bus. But we can, without any code changes, extract certain components, and that way we can start developing with a monolith. And then once our project evolves, we learn more about it, maybe we have more teams, we understand the domain better, we can start pulling out specific components into their own microservices instead of starting straight away with microservices, which may not be ideal at the start of a project. Right, so that looks something like this. So if we have one single component, it's all easy, right? To have that, that's because we just need a local message bus. We can use Axon Framework for that, indicated by that logo that you see in the middle. All these components, they just communicate with Axon Framework, and then Axon Framework has the message buses that take care of all the routing of all the messages and getting the responses back if needed. Very simple. Now, once we start to extract stuff, we need a distributed message bus. In the old days, what would we do? Well, you can use Postgres, for example, for an event store in between, so you can distribute your events. For your event sourcing, you can use RabbitMQ to stream your messages as well. You can use some kind of service discovery to find locations where you can send commands to. So with some additional components, you can actually do that distributed messaging. Only for commands and events, though. For queries, there's actually no support for any of these. You would have to do something custom. But later we'll actually see a better solution, so don't worry. A downside of this, if we start extracting this more, then we start to increase this amount of infrastructure. So we get more arrows. Every arrow means certain configuration, connections that need to be maintained, etc., etc. And even more if we start to do auto-scaling of those instances, because typically you don't run single instance of an application, right? You run multiple that maybe scale automatically or not. The amount of connections and configurations that we have will start to increase significantly. So this is really not, although possible, not the ideal situation. In a bit, we will actually see a better solution. You may already guessed it, considering that this is called the Axon Server intro webinar, but we'll see that later. Because first, we're going to look into the event store. An event store is a single source of truth, or actually, we store the events in there as our single source of truth. Now, what does that do, that event store? Well, it stores published events for two reasons, really. One, to be retrieved by the consumers. So anyone that's interested in those events can retrieve the events from the event store, do with it whatever they need to do. But if you do event sourcing, the event store will also allow the publishing component itself to obtain those events again. Let's visualize that, because that may require a little bit of explanation. So let's say we have two parts of our application. We have a command side on the left-hand side, and we have some query side with some projections on the right-hand side. In the middle, we have our events. And whenever something happens, we send a command to our command side. We validate our business logic, right? In this case, we're just validating the current state of an aggregate or of an entity. And based on that, we can publish an event. And then on the other hand, on the other side, we can listen to that event, manage it in whichever way we need to manage it there. In this case, we're just going to update some kind of projection. This is called event streaming. So event streaming is really all about getting your events from A to B. Now let's, for a second, ignore that query side. Not so important anymore. It still exists, but we're not going to focus on it now. And let's say at the command side, we are no longer going to store the current state of our domain model. Instead, what we are going to do, whenever a command comes into our command side, we are going to read all the relevant events from the event store. So for example, the events for that one single aggregate that's going to be handling the command. We're going to handle those events one by one to rebuild the current state. So we just rebuild the current state on the fly. We can do all our business logic with it, and then we can publish an event. Now, this part is called event sourcing. So event sourcing has nothing to do with downstream applications. It has nothing to do with query sites, projections, etc. Right? It's really all about how do we build our command model. So how do we store the state of our aggregates based on which we do our reasoning? Now, for both of these, event sourcing and event streaming, you do need that event store in the middle with certain capabilities so that we are able to satisfy both of these requirements with one single component. But first, you may actually think, well, why bother with that event sourcing, right? Why don't we just store the current state and that's it? Be done with it. So we can do that like this, right? Just on the left-hand side. We have some kind of order, we are a web shop here. And why don't we just store, okay, we have an order with an ID, some items in it, and a current status. In this case, the return shipment has been received. Yes, theoretically, we could just store that, but we'd lose a lot of information because if we look at the right-hand side at these events, there's actually a lot more that's going on. We can see that initially 2 items, 2 deluxe chairs were added to this order, and then 1 got removed. And then afterwards, we can also see the whole status of what has happened during shipment and during with that order, right? The first order got confirmed, then it got shipped, then it was actually the user that canceled it, and then we received the return shipment. So instead of just that 1 item, right, we have now more information on those 2 items, and we have the whole status information. So there's way more valuable information on that right-hand side. So on that left-hand side, we lose information. On that right-hand side, we do not. And we also have a free audit log. So if we use that right-hand side only, also to do reasoning on any new subsequent events or commands, how we handle them, then you have your perfect audit log, you have your single source of truth in those events. And you can just forget about the left-hand side because you can rebuild it on the fly whenever needed. Now, of course, in order to be able to do that dimension, right, we need that event store in the middle. So we need that event store that has these capabilities. So what is an event store? Well, it's a very specific type of data store. Because for starters, because events don't change, an event store is a write once, read many store, right? So we keep appending events, we append new events, but we never delete them. We never update them neither, right? We just append new events. So that's a very specific requirement, which you can do with many technologies, but also something that with certain technology, you can take advantage of that way of usage, right? Now, potentially, it can grow to a very large size. You can imagine if we don't update or delete those events, but we just keep adding new events over the course of some years, this can potentially grow to a very, very large size. Shouldn't be too big of a problem. There's always all kinds of ways to manage the costs of storing that on disks. But it is something that we will need to be able to manage because we need to optimally be able to read those events back whenever needed. And also store them, append them in an efficient manner. Now, next to that, you can imagine if you have 2 different events, if you handle one before the other or vice versa, can have very different end results. So whenever we store events, we need event store to provide very strict sequencing guarantees. If not, we can have all kinds of inconsistencies later down the line. It's just a recipe for disaster, really. And event replaying must be efficient. So whenever we want to read events, either all the events, just to consume the entire stream, or to pick out specific events for a single aggregate, we need to be able to do both of those types of reading in an efficient manner. So let's look at what kind of options we have for that event store. And one of those, as we also saw in that previous diagram where we talked about messaging, it could be a relational database, right? A relational database, though, has a focus really on data and entity structures. And it has very efficient support for CRUD operations, but actually we are only doing the C and the R of CRUD. We're not updating or deleting anything. So we don't need that support for the update or delete, right? We just need support to be able to efficiently create. And what you will notice with relational databases, that as those collections grow in size, and really here we're talking about data, right? We don't care much when it comes to events about that entity structure, the data structure. So when you start to deal with very large collections of opaque data, these relational databases will suffer a performance loss, right? If you're really talking about millions and millions of events, to update those indices, for example, on a table, gets more and more expensive the further your database grows. So although possible to use a relational database, it's definitely not the ideal solution. An alternative, if we really want to deal with those high volumes of data, well, NoSQL solutions, right? They could be very good solutions there. They simply focus on key value relationships, and they're very highly efficient, but also eventually consistent. It's how they achieve that high efficiency. However, because of the sequencing guarantees that we need from our event store, we cannot take full advantage of all those efficiencies through that eventual consistency of our NoSQL event store. So again, yes, it's possible to use, but you lose a lot of those advantages simply because we have very specific requirements in that strict sequencing that we need. Or you can also use Kafka as a messaging solution. Kafka is very good at messaging at scale, but Kafka is not aware of what is sent with it. So there's no sequencing guarantees, right? And we cannot do those aggregate specific replays. We can only consume the entire stream. We can't say, okay, I want only these specific messages from the stream. As such, for us event sourcing, it is not a good match at all. It's only useful for event streaming. Now, so here we've seen three options, right? Each has their disadvantages. So let's look at Axon Server. Let's see how Axon Server can meet those requirements, because Axon Server really was built from the ground up to meet them. So I'm going to show you how it did that. So first of all, Axon Server is built with that command, event, and query routing and event sourcing in mind. What does that mean? Well, it means that Axon Server has a command bus, an event bus, and a query bus for that distributed message routing. And Axon Server doesn't need to know, it's not an enterprise service bus, right? It doesn't need to know about the content of messages. It just needs to know about the type of message. And for each of those types of messages, because it has its dedicated bus, it can use the correct routing pattern and service discovery to get that command, event, or query from A to B, and potentially get the result back as well. So it's really built up from the ground with that in mind. Now, as far as event sourcing, right, it's a high performance, zero configuration event store. So the advantage with Axon Server, because the way it is built, because the way it manages indexes, for example, appending the very first event is just as fast as the pending event number 5 billion, right? It has a constant performance. So even though our event store grows and grows and grows, over time, we're still going to be efficient, both in appending, but also in reading. It uses some kind of segmented storage where it basically stores events in blocks. The older blocks, because events don't change, will never change neither. And we only have one current block that's open, a current segment to which we'll be appending events. Once it's full, we'll open a new segment, close all the other ones. Those old ones will just remain read-only. We can leverage that to search and read as fast as possible. As I mentioned, right, it's optimized to store events, so it's really taken into account that the fact that although you can update and delete events, it's not something that you would use in a normal day-to-day operations, right? It's really a special transformation API that you would use for that. So it's really focused on appending those events and reading them. Now, originally, Axon Server was built as a companion product to Axon Framework applications. So that's for Axon Framework applications, which is a Java framework, so any JVM language, you can use it from any framework there. It's written using an open API, Axon Server. It uses protobuf and gRPC. For Java, there is the Axon Server connector, which does all that managing, and you don't need to worry about dealing with protobuf and gRPC yourself. So any conforming client can use Axon Server. Nowadays, though, over time, Axon Server has definitely changed, and it contains now Axon Synapse, which is just a REST-based application that forms a bridge between any application that wants to talk to Axon Server in REST and Axon Server itself. So you can use it from everywhere. With that, we can then move from this complex setup, this complex infrastructure with all these arrows and all this configuration going around, and we can simplify it to this, where we say, okay, we just have one single component in between all our microservices. Each microservice registers with Axon Server. It informs it of its capabilities, of its needs. Axon Server then contains the message buses and the event store to store all your events. And you don't really need to do any further configuration of that, right? You just set it up once. You can scale them without issue. You can add new applications, remove them. You can transform all this with very, very, very little configuration changes, if any at all. So with that being said, right, I think we've seen now how we can leverage Axon Server as that single component that connects all our applications together. And it routes our messages, it stores our events, so it covers a lot of our needs. So let's look a bit more in detail. What can Axon Server do, right? What's the features that we have available to us here? Now, as I mentioned in the beginning, there's basically two feature sets of Axon Server. There's a standard feature set that you get for free. If you get an enterprise license, you also get some additional features that, especially for production applications of high importance, are very useful. But let's start with just, well, what do you get out of the box in your standard Axon Server, right? You get that zero config messaging. So you get that idea of, okay, you just connect your applications to Axon Server, right? You just really connecting them. It's just a matter of pointing them to a URL where they can find Axon Server. And then in the communication between the application and Axon Server, they inform Axon Server of the capabilities, of the needs of that application. And then Axon Server takes care of the rest from there on out. So it does that service discovery through that. You get your event store as well in the standard edition. And you also get a couple of ways to manage your Axon Server. So there's a management UI. So a web application, you just go there, you can have a dashboard of Axon Server, you can see stuff, you can manage stuff. But alternatively, there's also a REST API for managing Axon Server and a command line interface. So you can pick how you want to manage and configure Axon Server. Finally, in the standard, you do also get role-based access control, both for users and for applications. But it's relatively straightforward. If you go to enterprise, you get way more powerful control there, right? Because enterprise has support for multiple application bindings, which basically allows you to give different roles per application, where you can say, okay, this specific application, it can do these operations, and this specific application can do this, etc., etc. So you have way more fine-grained control there. Another really big advantage of enterprise is that it has support for consensus-based clustering. So where with your standard features, you just have one single Axon Server node. With enterprise, you have a cluster. And it uses the RAF protocol to have a consensus-based connection between them and data duplication, really. So replication, I should say. Now that allows you to really not have that single point of failure, right? Because with the standard edition, and that's why standard edition is good for initial tests or low impact applications, but you do have one single machine with one single Axon Server running. So if that machine were somehow to fail, you do have a failure there. With enterprise, because you have that consensus-based clustering, you have way more options there. If one node fails, it doesn't matter, your cluster will still be alive. And you can even go further by giving different nodes different roles, so you can make your cluster setup as complex or as simple as you want or need it to be. Enterprise also allows you to use multiple bounded contexts. So within Axon Server, you have an event store per context. With standard, you just have one default context. With enterprise, you do have the option to create these multiple bounded contexts. That allows you to then separate certain events from others, right? So you have way more control over how you configure that. Now, enterprise also allows you to have geographically distributed and localized context, so you can decide where things live in the world, really. And it allows you, once your event store grows, that's going to be important, to use tiered storage. Tiered storage basically means that we can take advantage of the fact that most of the time you will really be reading the most recent events. So all those old events, you want to keep them, of course. You may need them every once in a while, but you might not want to keep them on your fast, expensive disks. You might want to move them to a lower storage tier, where the files will then be moved to a cheaper disk, for example. So that can significantly lower your operational costs. You can even go as far as using ephemeral tiers, where you say, okay, after a certain amount of time or after reaching a certain size limit, we're actually going to delete these events. Something to be used with caution, but in certain scenarios, it can be very powerful, very useful. Then there's also that event transformation API. I already mentioned that a little bit on one of the previous slides, right? With that event transformation API, it allows you to update or delete specific events from your event store. Not something to be used on a day-to-day basis, but it can be very useful if you need to comply with certain legal requirements, or if you made some mistake in the beginning, right, and you really need to fix that. You can use that event transformation API for that. It also supports multi-tenancy together with a extension inside Axon Framework. And the authentication and authorization you can also do with enterprise, not just with basic authentication, but using LDAP, OAuth, OpenID Connect. And finally, with enterprise, you get support for data protection through a plugin, or alternatively, you could use a model inside your Axon Framework application. Now, what does that data protection do? Well, let's take, for example, the GDPR regulation in Europe. Through the GDPR regulation, you need to be able to allow people to delete the data, to modify the data, right? Which, well, deleting data doesn't play so nicely together with having to having your events that you do not want to update or delete, right? Now that's where data protection comes into play. So instead of deleting the data, you can just store it from the beginning in an encrypted format. And then when the time comes to delete the data, what you do instead, you throw away the encryption key. Then the event will still be there in the event store, but those specific privacy sensitive fields will no longer be accessible. So effectively, they will be deleted. Okay, so let's look then at our application landscape with our supporting services. A typical application landscape might look something like this, right? So you have all kinds of microservices that are running somewhere, right? We have a Java here, Node.js, Python, Go, .NET. Because why not let's use 5 different languages in one go? But we need certain supporting services to be able to manage those microservices, right? We need deployment services. We need probably some kind of API management. We need some kind of authentication or authorization. We probably have to deal with secrets, so we need some kind of secret management tool. We may need to do some protocol transformation, especially considering we have multiple different languages. We need to do service discovery, message queues. We're going to need to get messages from one place to another. And we're going to have some kind of managed storage that we need for each of our microservices. Now, if we look a bit further into these messaging and event sourcing applications, then we actually get 2 more requirements added. Because we want to send those commands, those events, and those queries and handle them, we also need support now for an event stream. We need to be able to stream our events from one place to another. But we also need an event store. We need to be able to do that event sourcing so we can recover very specific events to rebuild our domain model on the fly and do our reasoning on it. Now, service discovery, the message queue, the event stream, and the event store are all taken care of by Axon Server. Because Axon Server provides you with messaging, it has handler discovery, it allows you to do that event streaming, and it contains the event store. It is an event store, really. If you added Axon signups to it, then you also get your protocol transformation, because you can have these non-Java microservices simply talk to Axon signups in REST, using HTTP, and there we convert it over into gRPC. So here you'll actually see that, well, of course, Axon Server cannot take care of all your requirements, right? For example, it doesn't have secret management. For that, you will still going to be using some kind of vault. For authentication, you may still want to use some kind of LDAP system or something along those lines. But it does actually take care of a big bunch of your infrastructure needs to be able to deploy and manage your microservices. Now, with that, I hope I have piqued your interest. If so, you may want to get started and just give it a shot. How would you do that? Well, there's actually 2 ways to get Axon Server. The first one is just a Docker container. So it just available on Docker Hub, Axonic/Axon Server. There you can just get the latest version or a very specific version of Axon Server if you want to. Alternatively, if you don't want to run it in a container, you can just download a runnable jar. You can go to developer.axonic.io, press the download button, and then you can simply download the latest version. Here to the right, if you're new to this, you can completely ignore this, but for those that have been working with this a bit longer, for the older versions, we actually had a separate jar for the standard and enterprise feature sets. Nowadays, it's just a single jar. So you just click to download the latest version and you're good to go. However, if you want to unlock those enterprise features, you can also simply request a 30-day trial. It's for free. You just fill in a form. You get the license file valid for 30 days. So you can go further than just testing the standard functionality, but you can really go and try all the full feature set of the enterprise features. The license works either with your container or with your jar, however you want to run it. That's entirely up to you. Now with that, there's some time for questions. So if you have any questions, please feel free to type them in the chat. In the meantime, while some of you may be typing, or at least so I hope, I want to point you to what we've actually been seeing the whole time at the bottom of the screen, Axonic Academy. If you've gotten some interest out of this and want to learn more, you can go to academy.axonic.io. On there, we have a lot more resources, partly free, partly paid, where you have video courses explaining all these concepts in more detail, explaining how to use Axon Framework, how to use Axon Server, how to build your applications with it, etc., etc. So a lot of valuable resources there. I highly recommend to read them, to view them, because there's a lot of videos, there's exams, you can even get certificates with it. And considering there are no other questions, then we're going to just call it a day for now. And thanks a lot for your attention. And I hope to be in touch.